Good day, everybody. My name is Oussama Obeid, and I'll be discussing the first part of the chapter Mobile Technologies. Table of content is as follows. I'll be discussing a brief history and timeline of phones. Then we'll be discussing some key advancements and features over different areas. Then we'll go to the topics of memory and processing power. In 1973, the first ever mobile phone call was made by Dr. Martin Cooper. He used a prototype called the Dynatac phone. The phone weighed over a kilogram and took about 10 hours to charge. Moving to 1979, Japan launched the 1G, which is the analog telecommunication standards. In 1983, the first mobile phone goes on sale in the shape of the Motorola Dynatac 8000X. It cost an eye-watering $4,000. 1985, we finally witnessed the first ever truly portable mobile phone, the Motorola 9800X. Then, 3 years later, the launch of the Global System for Mobile Communication took place, and 2G digital cellular networks replaced the 1G analog system. 2G made text messages, picture messages, and multimedia messages possible, creating a whole new way for people to communicate. 2 years later, IBM brought out the Simon, which had a touch screen and a very early form of what we know today as apps. It cost around $900 and worked only in 15 US states. Oh, Nokia also launched a 2110 in Europe. The first slider and flip phones were introduced in 1996. Nokia 8110 was the first slider phone, and the Motorola StarTAC is the first flip phone ever. It sold around 660 million units worldwide. In 1997, there was a lot of innovative releases and advancements. The iconic game Snake is launched on Nokia 6110, which marks the start of mobile gaming. Hagenut launched the Global Handy. Ericsson brought out colored keyboard panels, and Siemens bought us the first colored screen phone. Additionally, in the UK, Mercury 121 started the first ever pay-as-you-go service called Up to You. 1 year before the year 2000, WAP, which will be later discussed, launches the Nokia 7110, making it the first phone capable of browsing the internet. It was the trimmed down version of what we know today as HTML. In the year 2000, Sharp JSH04 becomes the first camera phone on the market, but only available in Japan. BlackBerry launches their 857 phone, which supports email and web browsing, signifying the start of BlackBerry's reign as the business phone kings. Nokia also launched perhaps the most iconic phone of all time, the Nokia 3310, which sold around 126 million units. 1 year later, full-color display starts to hit the market. 2003, 3G networks begin to roll out across the globe, being 10 to 3 times faster than 2G. This enabled users to watch video clips, participate in video conferences, and utilize location-based services for the first time. 2005, Android, the mobile operating system, was acquired by Google, which sent the message that the Google giants were serious about mobile technology. Then in 26, the Nokia N95 launched, providing the first real smartphone experience. It ran on Symbian, had 160 megabytes of RAM, and the world's first 5 megapixel phone camera, Bluetooth, and Wi-Fi. In 2007, we witnessed the release of the first generation iPhone, which was a huge success. 2008, the first Android phone is released called the G1. And parallelly, Microsoft decides to bin window mobile citing that it cannot compete with iOS or Android. It begins working on a brand new operating system, Windows Phone. Apple also launches the App Store with 552 available apps to download. 2009, Sweden and Norway's TeliaSonera become the first operator to offer customer 4G services. Practical term, 4G is 5 times faster than the speed that can be achieved over 3G. 2010, Apple launches the iPhone 4. In 2015, 4G data traffic surpassed 3G for the first time. Although 4G represents only 14% of mobile connections in 2015, it already accounts for 47% of mobile data traffic. 2017, Microsoft ends support for the Windows Phone operating system, just 7 years after its response to Android and iOS. Additionally, we witness SMS messaging celebrating its 25th anniversary. However, although it struggled to gain widespread adoption due to poor coverage at the beginning, it now transmits around 22 billion messages daily. 2018, China manufacturer Lufan launches the Power 5, incorporating a 13,000 mAh battery, the largest ever seen in a mobile phone, over 4 times greater than Apple's flagship. Finally, 1 year ago, we were introduced to 5G.
After this introduction from my colleague Oussama presenting the timeline and history of mobile technologies, we move on into the advancements and features that we have witnessed throughout the years. First of all, we're going to talk from 1983 to 1990 with the first ever portable mobile phone, as we can see in the image, which is the Dynatac 8000X. Early cell phones were just for talking. Gradually, many features were added, but the main purpose was talk. Therefore, the only feature of this era was simply mobile calling. What happens exactly is that your phone converts your voice into an electrical signal, which is then transmitted as radio waves and converted back into sound by your friend's phone. We move on to 1991 to 1994. The main features from this era are SMS and games. When a friend sends you an SMS message, the message flows through the SMC, which is the short message service center, then to the tower, and then the tower sends the message to your phone as a little packet of data on the control channel. As for games, the earliest known game on a mobile phone was the famous Tetris message. We move on to from 2003 till 2006 with the mobile data revolution. The main features from this era was real-tone ringtones and the Nokia 3300 in 2003, with the augmented reality in the Siemens SX1. In fact, augmented reality, or AR, is an interactive experience of a real-world environment where the objects that reside in the real world are enhanced by computer-generated perceptual information, sometimes across multiple sensory modalities. The most important feature until our current life is the Wi-Fi, which was in fact founded in the first phone of the Calypso C1250i in 2003. Wi-Fi works off of the same principle as other wireless devices. It uses radio frequencies to send signals between devices. And to receive the information found in these waves, your radio receiver needs to be set to receive waves of a certain frequency. For Wi-Fi, this frequency happens to be 2.4 gigahertz and 5 gigahertz. Quad band, which is the improvement of tri-band, founded in the Sprint PCS International phone. In fact, it's a phone that supports 4 different radio frequency bands. Different mobile phone networks around the world use different bands. A phone can only be used on a network if it supports the correct band. Quad band usually refers to a phone using GSM technology, as we previously explained. A quad band GSM phone is one that can be used for basic service almost anywhere in the world. The 4 bands include the 850 and 1900 megahertz bands used in America, and 900 to 1800 megahertz used in most other parts of the world. We can talk also about waterproof and the Casio GZ1 in 2005, and the full web browsing and the Opera Mini. In fact, a browser is a software application used to locate, retrieve, and display content on the World Wide Web, including web pages, images, video, and other files. As a client or server model, the browser is the client run on a computer or a phone that contacts the web server and requests information. The web server sends the information back to the web browser, which displays the results on the phone or other internet-enabled device that supports a browser. As in from 2011 to 2004, entitled Generally Live Companion. The main features from this era are voice control, firstly invented by Google Voice Control in 2010, the dual lens camera and the HTC Evo 3D. In fact, a dual camera setup increases an image quality by having 2 lenses first divide the work before working together to to produce higher quality images. The monochrome lens cancels out the RGB lens color filter array, making every pixel emit light 3 times that of the color sensor. We can talk also about the facial recognition, which is a system that uses biometrics to map facial features from a photograph or video. It compares the information with a database of known faces to find a match. Facial recognition can help verify personal identity, but it also raises privacy issues, such as passwords. Fingerprint scanning. Fingerprint scanners work by capturing the pattern of ridges and valleys on a finger. The information is then processed by the device's pattern analysis or matching software, which compares it to the list of registered fingerprints on file. We can talk about full HD screen and heart rate monitor. All the features added in this era have become our day-to-day used features, which facilitate our lives, such as the voice control and the Google voice control. And finally, from 2015 until 2018, the main features from this era is the iris scanner, the Apple and Android Pay. Like Apple Pay, Android Pay is a mobile payment system designed to let people purchase items and services both online and in the real world. It also uses NFC hardware on Android phones and also stores credit and debit card information. We can talk about bezel-less screen. In fact, bezel-less means all display and no borders. Bezel-less phone are the future, and that's where the industry has been pushing. Many manufacturers are taking different approaches towards this new trend. We can talk also about the notch, which is essentially a cutout at the top of a part of the screen display. Its advantage is it offers the ability to retain the display space on either side of it for information such as date, battery statistics, and more, and for apps. And finally, we can talk about the improvement of the regular fingerprint scanning, which is the in-display fingerprint sensor in the Vivo X20 Plus UD, which was invented in 2018. Thank you.
This part of the presentation discusses memory in cell phones. Memory has always been a concern for cell phone producers, but to us users, it has been merely a spec, which we have taken for granted. Increasing phone storage while maintaining the small size of a typical smartphone poses a huge obstacle for tech giants. Ever since Nokia launched its N91 phone in 2005, which had 8 GB of internal storage, companies have engaged in a memory war whereby each one of them wants to provide the market with a new and enhanced memory technology. And since then, we have seen unreal numbers in the memory domain, such as 512 gigabytes, 1 terabyte in memory in phone storage, which is these numbers are relatively low as compared to the numbers seen in external storage devices such as hard drives, which can go up to 16 terabytes. What is a memory exactly? Every cell phone memory is built in a different way. There is nothing stable, but the basics are there everywhere. The RAM, the internal memory, and the SD card. The RAM. RAM means random access memory. Its name indicates its usefulness. Random data, random commands, everything temporary which applications use as data or as input is stored in the RAM. The commands, the progress of a game, and stuff like these are stored in the RAM. This is why the RAM is not permanent. The operating system deals with cleaning the RAM, deleting data relating to an application when it is closed, so that space is freed up for new applications that would run in the future, and so on. There is a misconception regarding RAMs. People believe that expanding the RAM allows user to download more data, applications, take more pictures, and so on. But expanding the RAM only means that the phone can now run more simultaneous processes faster and more efficiently. But this expansion of the RAM comes at its cost. Building the RAM chips is very expensive. In addition to them being very costly on power, they dissipate too much power. This is why RAMs usually have small sizes, 2, 3, 4 gigabytes, such as in iPhones. The new Samsung has seen the record high for a RAM, which is 8 gigabytes in a smartphone. And this is the RAM. Onto the internal storage. The internal storage is flash memory. Flash memory means that it is built into the phone, and it can't be changed. You can't increase the size, decrease the size, except using SD cards, which will be discussed later. But mainly, it can't. No additional size can be added to it. The internal storage is divided into two parts: the ROM and the data storage. ROM means read-only memory, which means that only the system could read from this part of the internal storage. This part usually contains the operating system. The next part, or the other part, is the data storage. It is where every single download, installation is stored. Every new application is stored in the data storage. And a cool feature about this data storage is that an application can only modify its own files inside the data storage and can't access those of other applications. Some examples of modifying the data storage include deleting photos, taking photos, deleting applications, installing applications, and so on. On to the last part of the memory of a cell phone, the SD card. The SD card is rather different than the RAM and the internal storage because it is not built into the cell phone. It is an external chip which could be implemented or placed inside the cell phone to add more storage to it. It can be configured in such a way in the settings to be used as internal storage, but some phones don't allow so, such as iPhones. Meanwhile, Androids do allow. iPhones have opted to using cloud storage instead of these SD cards. To the left, you can see an SD card of 1 terabyte, and to the right, we can see a device produced by Apple so that the iPhones could read data from the SD card.
Okay, this is Kaakour, and this is concerning processing power. The first was the development of the ARM microprocessor, originally designed in the early 1980s by Sophie Wilson and Steve Ferber at a British company called Akron Computers. At that time, ARM stood for Akron Risk Machines. It is now a separate company called Advanced Risk Machines. ARM chips are important because they very efficiently feed instructions to circuits on the microprocessor, providing abundant computing power while demanding comparatively little energy. Most smartphones are now fitted with ARM microprocessors. The low-power processor means that impressive computing can be fitted into a package with a small battery. Smartphones have become progressively thinner and sleeker, light enough to drop in a shirt pocket. At the same time, they have acquired an ever-increasing array of features such as a touchscreen, GPS receiver, in addition to standard cameras and music players. Phone memory and processing. To put that into more concrete terms, the latest phones typically have 4 gigabytes of RAM. That is more than 1 million times more memory than the Apollo computer had in RAM. The iPhone also has up to 512 gigabytes of ROM memory, That is 7 million times more than that of the guidance computer. But memory isn't the only thing that matters. The Apollo 11 computer had a processor, an electronic circuit that performs operations on external data sources, which ran at 0.043 megahertz. The latest iPhone's processor is estimated to run at about 2,490 megahertz. Apple do not advertise the processing speed, but others do calculate it. The processor of your phone is one of the most important features about it. In simpler words, powerful CPU allows you to process data faster, which means faster application opening, faster web pages, and faster gaming. On another hand, it helps your phone handle multiple tasks at once. Now we're going to take a fast look on some of the most powerful mobile processors. The first processor is the Exynos 8895. It is a Samsung processor. It was announced in early 2017. First appeared in Samsung Galaxy S8 and S8 Plus, has Samsung's second generation quad-core custom CPU. The second processor is the Snapdragon 845. This processor is special because it has a CPU clock speed up to 2.8 gigahertz and is a 64-bit CPU. The third processor is the Kirin 980. It is known for its Cortex A76 CPU and has a performance up to 75% and power efficiency up to 58%. Finally, the best processor among all is the Apple Bionic 13. It is the new Apple processor. The Apple A13 Bionic is a 64-bit ARM-based system on a chip designed by Apple. It appears in the iPhone 11, 11 Pro, and 11 Pro Max, and the iPhone 2nd generation. It has a 6-core CPU with 2 high-performance cores running at 2.65 gigahertz called Lightning and 4 energy-efficient cores called Thunder. The Lightning cores feature machine learning accelerators called AMX blocks. Apple claims that the 2 high-performance cores are 20% faster with 30% reduction in power consumption, and the 4 high-efficiency cores are 20% faster with 20% reduction in the power when compared to the A12. The A13 also integrates Apple-designed 4-core graphics processing unit GPU with 20% faster graphics performance and 20% lower consumption than A12s.